Good afternoon, good morning, good evening. My name is Dr. Thomas Selover, an international coordinator for the International Association of Academicians for Peace, which is our host today, and I will be serving as your moderator. So let me first remind everyone to please be on mute until it comes to your speaking time, and that will help all of us. Just like to say a word about IAAP. It's designed especially for academic discussions on critical issues in our time. And it's one of the pillar associations of the Universal Peace Federation, UPF, which was founded by Reverend Dr. Samyang Moon and Dr. Hakchahan Moon in 2005 in order to rejuvenate the United Nations and to advance initiatives for peace throughout the world. After Reverend Moon's passing in 2012, Dr. Hakchahan Moon has continued to advance this vital work. You can find more information at upf.org. Our theme today, as I believe you all know, is climate change, from big picture to potential crisis. It is indeed a critical topic and a hot topic, as daily news feeds are full of conflicting statements and reports and warnings about the severity and causes of climate change, that is global warming. For today's program, we have invited two distinguished scientists and a well-informed commentator to help us with the issue of climate change. Not so much what to think, but how to think. That is, how to weigh differing opinions constructively. Before introducing our speakers, let me briefly go over our format for today. Each of the presenters will have approximately 10 to 12 minutes to give their presentations, and then we'll hear from our commentator. After a bit of back and forth on the panel, we'll turn to questions from our audience participants. And so therefore, I'd like to ask you, please be thinking about your questions and write them into the chat box. We'll use the chat box as our medium for getting the questions to the presenters. So please write questions down in the chat box. Please keep them concise and also respectful. As a reminder, we are live streaming on Facebook and YouTube, as well as at the UPF website, us.upf.org. We'll end the program officially at the 1 hour mark, and we'll probably have a few minutes of informal conversation beyond that for those who would like to stay and participate. And we're hoping that our speakers will be available to do that. Now then, our first presenter is Dr. Takahiro Hiroi. Dr. Hiroi is a planetary spectroscopist who earned his PhD in mineralogy at the University of Tokyo in 1988, with a focus on reflectance spectroscopy of meteorites and asteroids. He is currently a senior research scientist at Brown University. He's coming to us today from Brown, his lab, and also a professor at the World Research Institute for Science and Technology, known as RIST. Dr. Hiroi's pages at the Brown University website provide a long list of his research papers in English, I think, and in Japanese, actually in a special kind of English that most of us can't understand. His research paper, his presentations, and his lectures. He's contributed to Japanese planetary exploration missions, as well as the ongoing NASA OSIRIS-REx mission. And in 2000, the asteroid 4887, Takahiro, was named for him. So if you look up in the sky, he's there as well. Amid all of his research work, Dr. Hiroi still finds time to regularly lecture to high school and college students in Japan, America, and other countries to inspire them to aim high. Dr. Hiroi, we are looking forward to hearing from you. The floor is now yours.
Yes, thank you for your wonderful introduction. Sometimes I wonder who you are talking about. I did not mean to accomplish that much. All right, let me share my screen. Okay. All right. Uh, sorry. Okay. Today, I like to talk about just a big picture of climate change of this planet Earth. As you know, our planet is 4.6 billion years old. And then we have important elements other than sun and the earth. We have Arctic and Antarctic regions of ice, and also the moon. That is very important. Um, I think second speaker Andy will be talking about more recent events, but I'm talking about billions or hundreds of millions of years of story. Now, one thing, it's a little professional, I mean, a specific term, but this is such as so-called Milankovitch cycles is important idea that is about the inclination of the Earth's spin axis that is highly stable for the last billions of years because we have a very heavy moon beside us that is stabilizing this spin axis. If this spin axis becomes flat, you can see the half year daylight and half year night side, that will be catastrophe. So uh, first of first of all, the moon is a climate regulator of the Earth. And then we have Earth orbit around the sun. It's a little elliptical. This is not this elliptical, but like 0.05 as opposed to zero point 0.5. So this eccentricity change makes solar radiation change. And also we have an inclined orbit around the sun, and also we have a precessing motion that is uh, perihelion and aphelion. They move through years. So these kind of orbital elements combined, they make solar radiation or solar forcing that is a radiative heat onto the Earth change like this. So, so this is the time span of about less than 1 million years in this plot, but it has been going on for a long, long time. And then the actual temperature record, you can see examine and estimate the past temperature based on the oxygen isotope. Oxygen has mainly three isotopes, 16, 17, 18. And then minor amount of heavy oxygen isotope 18, uh, the amount of 18 fixed to the plant or ice or rocks, they change according to the temperature. So we do know the history of temperature change. And then that is not exactly based on the model, but the cycle seems to coincide with it. So this is basically simply based on the planetary motion, how much sunlight energy coming into the Earth. However, temperature also depends on the atmospheric condition. So this is for the last 4.5 billion years, what kind of atmospheric gas we had. As you know, all the planets are rich in carbon dioxide in the beginning. As you can see, our neighbor planet, Venus, almost the same size with Earth, but closer to the sun. It has so much carbon dioxide, and then that's global warming due to greenhouse gas effect. So all the water probably vaporized. So however, uh, in the case of Earth, at one point, instead of carbon dioxide, oxygen started to increase due to biosphere and other effects, and the methane decreased. So at this point, greenhouse gas, carbon dioxide, and even more greenhouse gas, effective greenhouse gas, methane, has been at the lowest level for over the entire, almost entire history of the planet Earth. And then thanks to that, to oxygen, we animals can live. However, the plants needs carbon dioxide. So for the plant life, this level is critically low when you think of their from their footprint. So and then these plots more recent plot. Instead of 4.5 billion years, it's about zero point 0.5 billion years or 500 million years. Uh, Geologists today discovered fossil records of a Cambrian explosion. That is means the species were coming from the ocean to the land, and then so many species like explosion, they evolved into diversity. At that point, CO2 level, as opposed to this level, these are models, different models. But the current level, 0. About 300 milli ppm, is almost the lowest level, roughly speaking, 200 to 300. However, 500 million years ago, we had probably about 10 times more CO2. Still, it's only 3,000 ppm. That is much lower than 1%. At that time, still, life evolved and flourished. What about temperature? Temperature varies so much. However, in general, that at that time we had about 15 degrees C higher temperature. But still, the species on the Earth were okay. Actually, they are flourishing. Uh, I will show more evidences of recent, effect on these conditions. One information that not many of you may be aware, on Antarctica, you may be seeing many media reports that glaciers are melting, especially at the edge of Antarctica. These red parts, these are the parts ice was lost or decreased for the last 10 years or so. However, closer to the pole, this inner area, the temperature is much lower than freezing temperature. So as a result of higher temperature, we have more water vapor in the air. So the more precipitation as snow. So as a result, this blue area, they increased the amount of ice. So in total, plus and minus, about more than 5,000 square kilometer area increase. However, this is just the area, not the volume. But according to the other models, in terms of volume also, it's been increasing. But the increasing rate could have slowed down, but still increasing. Therefore, Antarctica has been actually preventing, ocean level not to become higher. It's trying to lower the sea level by being a buffer for excess water in the air. Now, about the vegetation, as I explained, CO2 is needed for vegetables, plants, and also higher temperature is always good for plants. As a result, for the last 20 to 30 years, according to researchers' results at Boston University, uh, these greenish colored areas, they increased um, based on the satellite observations, the leaf area increased. And these reddish or purplish areas, they decreased. So in total, uh, the estimate is, it's not written here, but about 20% of vegetation area increased over the last 2 or 3 decades. Therefore, we have more ice in Antarctica, and then we have more vegetation, and then higher temperature. So at least for the vegetable life, plant life, everything is good, and the ocean level is not as high as where no Antarctic buffer did not exist. Now, on the contrary, people are scared of rising ocean level. So this is a map taken from Wikipedia somewhere on the internet. What if ocean level rises by 100 meters? Of course, this will not happen within the next century or so. You can see, a lot of land, especially in South America or Australia, is lost, and India maybe. However, you still have a lot of land in Africa, North America, in Asia, and even Japan and Korea, they still remain as islands. Therefore, you will have, and we will always have lands to live or migrate to, even if there's a higher ocean level or higher temperature. Uh, when when it's too hot, what would you do? You may climb up to mountains, or you go to a polar area, maybe so, right? I know many people in the United States who goes to Florida in summer from Boston. So that kind of migration is possible when temperature rises. But when you experience too cold temperature, even in Florida, where would you go? Maybe you have to go to like Bahamas or somewhere. But in the end, you may not be able to escape from coldness. But from warmness or hot weather, you probably have always a place to go. So in summary, in my opinion, global warming and CO2 level increase is not a problem for life in general on the surface of the Earth. As I said, people can always move to cooler areas at the high latitude or altitude. On the contrary, uh, if global cooling occurs and the CO2 decreases, what happens? Then the plant life may die. That means food will be gone, the animal life will die, and we die. And then cooler temperature, you may have nowhere to go, maybe underground, but you have no sunlight there. So what we have to think of is this planet Earth will be okay with global warming at this rate. However, if the national boundaries exist to prevent people from moving to a better climate, that's a problem. So, in my opinion, nations in the future should not have a conflicting relationship around the border. We should pursue, always peaceful coexistence, or we can eventually eliminate national boundaries to allow people to live in a comfortable climate. So I think this is it for my slides. So I stop share maybe. Okay.
Okay, very good. Very good. Thank you very much, Dr. Hiroi.
Okay.
Thank you for your elevating and in some ways comforting perspective, kind of
Yes.
long term. We should fear cold more than warm.
Yeah. I'm an
Okay.
optimist. So
Optimist, the optimist.
yes.
Okay. Then now let's turn to our second presenter, Dr. J. Andrew Combs. Dr. Combs is educated in the fields of physics, meteorology, and condensed matter physics. He obtained his PhD from MIT based on research in soliton physics and molecular dynamics. Dr. Combs co-founded the World Research Institute for Science and Technology, known as RIST, which was named and motivated by Reverend Moon in 1984, and whose lofty purpose includes the innovation in high technology and also exploring new science that reveals the unity underlying science and religion. He is also the co-founder of Interlinear Technology, whose software became mission critical to the Hubble Space Repair Mission in 1993. As president of RIST North America, he is active in research into climate science, non-invasive therapeutic innovations, in unified East-West medicine, and also the nature of energy and information transfers between here and there. Dr. Combs, we understand that your views on climate science have changed a lot over the course of your career, and we invite you to share your perspective. Sir, the floor is yours.
Thank you for your very nice introduction. I was going to give a slide on risk, but I think you covered it. I've retired from my academic duties, and I came into the understanding of climate science, interest in climate science because of students' questions, and you don't want to be wrong. So I had to dig into it. And I began really from a perspective of skepticism. There was ClimateGate in 2009 and so on. But over time, we like to build models to try to understand and explain what we're looking at. So I'd like to take you through that kind of path for a little while here. Let me share some slides here. And get it up onto the slideshow here. Here we go. So climate change is causes, what must be done. Really at the end, I feel there's a call to action. I haven't been concerned until recently. When you look at data and it stares you in the face and it has certain consequences, I can't help but draw certain conclusions and want to do certain things. This summer was a wake-up call. I don't know how many heard about Hurricane Otis. It just went through Acapulco. It was a tropical storm, and it was approaching Acapulco, and then suddenly in 12 hours, it became a Cat 5 storm. 48 people that I know of perished. It was shocking. And it's due to warming of the seas, and people didn't predict that. So a lot of unexpected things are happening that are costing life. Warm oceans went way beyond the most extreme over the past 40 years. They call it a 4 sigma event, but it's really 2 sigma, that is kind of 2 standard deviations away from the climate trend as we have it. And this is the summer where we started to experience this 1.5 degree centigrade heat above pre-industrial levels, which is really a climate change plus El Nino. And a lot of places suffered greatly. Canada was on fire, Greece, Lahaina burned to the ground, flood disasters, heat domes. These kinds of things have been predicted as a result of patterns of weather that change due to the warming, the loss of ice at the poles, and the kind of jet stream patterns that would naturally result. So I see trouble ahead. So I guess Taki is half full and I'm half empty. Maybe that's a typical story for me, I think. So warming is, our warming climate is due primarily to the accumulation of greenhouse gases. And I want to try to show how that comes about in terms of modeling and data. First, let's start with data. This is, as Taki was saying, I'll look at the modern versus the historical more. This is the observed global mean surface temperature, T sub S, observed over the past 150 years or so, since 1880. There are both thermometric and satellite measurements, radiometric measurements. It's about 1.1 degrees above those levels that were characteristic of 1750 or so. The wiggles are largely due to El Nino, La Nina, other ocean circulation oscillations, volcanic eruptions. And I can draw a trend line through that, and I would like to be able to have a theory that gives me that trend line. That's what modelers do, that's what theorists do. So we can see the date it's climbing, and let's see if we can get to something that tells us why. So here we go back in time to about 800,000 years ago. And Dr. Hiroi was talking about the Milankovitch cycles, which usually are albedo kind of, or Earth's reflectivity, which is the albedo kind of triggers for a dance between CO2 temperature and also sea levels in 100,000 years or so cycles. And they're basically range bound over that period of time. CO2 bound between 180 and 300 parts per million in these natural cycles, just change it at about 0.02 parts per million per year maximum. But you might look at the right-hand side of that blue graph, and it shows current, and boom, it exploded higher. Now, this is a long time scale, so it looks like a sudden jump, but it's been going up. We'll see a graph about that. At an exponential rate. It's going up at 100 times the natural rate, way beyond that upper bound to 400 parts per million and beyond. And these are man-made. I think even the ones that might agree with Dr. Hiroi that we should adapt wouldn't argue that this is really induced by our fossil fuel burning and release of CO2 into the atmosphere. Let's take a look at CO2 more a little bit. And you see its exponential rise. Now, this is from 1750 till now. The blue dots are data from ice cores up until 1950, and 1950 on from Mauna Loa. And you can see a very regular curve. I fit that to a certain curve that has exponential in it. And you can see it's just taking off. It doubles from its pre-industrial levels in about 30 years and reaches a point that turns out to be critical, we'll see maybe in the next slide, of 600 parts per million years, 40 years from now. Now that's coming on strong, having not varied much over a period of time, long period of time. We're accelerating. Now this is reminiscent of Dr. Hiroi's slides before, and you'll see there's a long-term history, the whole Cenozoic era of modern life, going back to 60 million years or so, and CO2 being way up in the thousands, or a couple of thousand parts per million, coming down, 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 breaking down into, say, 20 million years ago into the 600 parts per million area. And about 5 million years, or 3 or 4, 5 million years ago, we have beech trees in Antarctica. So, okay, let's move down there. Maybe many people would like to build, beach houses or things like that there. But that's when the Antarctic ice sheet began to coalesce and become stable. So it dropped, CO2 dropped down below that. And in the middle, you see these oscillations we showed before. And we're going into the modern era where it's beginning to increase again. Again, they're even calling it the Anthropocene era as opposed to the Holocene. So we are looking at somewhere between now and 600 parts per million where we're going to lose the Antarctic ice sheet somewhere, somehow along. If we continue business as usual, it's inevitable. Is that good or bad? Well, we'll have to think about that. Now, what drives climate change? In a word imbalance, Earth's energy imbalance is called forcing. Dr. Hiroi mentioned that. Basically, if there's an imbalance between sunlight coming in and the, you could say, Earth light going out, the infrared radiation going out from Earth, you're going to drive temperature to change. Key players are albedo, greenhouse gases. Albedo is reflectivity of the Earth, which rejects some of that incoming sunlight. Whenever you see a picture of the Earth, that is from the albedo part, that part of the albedo. Greenhouse gases trap a great deal of the outgoing infrared light, and the current rise of the temperature is driven almost solely by the accumulation of greenhouse gases. And there are complicating factors called feedback, which amplifies this forcing, and ocean response, which delays it. So let's just take a quick look at key forcing contributors, mostly anthropogenic. Warming goes up, cooling goes down. You see CO2 up there on the right-hand side. Other greenhouse gases like methane, nitrous oxide, CFCs. The forcing is dominated by greenhouse gases. There are other things in there: land use, blackening of snow, contrails. Aerosols is one of the things that mitigates that warming because of its reflectivity. And models are based largely on this forcing or the feedback mechanisms. So let's put something in there. It's a famous group out of Colombia put Cenozoic era temperatures and CO2 and albedo variables, and we're able to reproduce these ice age cycles. So they're with albedo and greenhouse forcing and these feedback mechanisms, they were able to nail the feedback multiplier and reproduce that time series. Now that's quite a remarkable thing. I think that's a great achievement. It means ultimately that for every unit of forcing, this watts per square meter, you're going to get 3/4 of a degree of centigrade temperature rise. And it must have been very satisfying for someone like Svante Arrhenius' 1896 prediction, which was higher, but he sort of kicked this whole thing off about warming from CO2. Now here we have models. So we made some models at risk. Those are the wiggles that we saw before. We have a model that has no feedback, that green curve. Then we also have another one that takes into this idea of feedback, and I call it half now, half later. And that does a very good job of modeling that general trend line. The long-term trend line there is built on a fit to CO2 that we saw earlier. And we get an accelerating rise of temperatures. 20 years out, we get 1.5 degrees, 40 years out, 2 degrees. And you can do much better with global circulation models or full linear response theory. Let me just wrap this up. For me, the idea that we can migrate sounds nice, but we're not nomadic people. We are really fixed to great cities, great infrastructures. Wouldn't it be sad if we see those things disappear underwater? It would be a very, very sad and tragic thing. I don't think people would accept that. I don't think people are that way. We're going to have more great fires and deluges. We're just beginning to witness these kinds of phenomena. So my recommendation, and risk recommendation, I would say, although Taki and I might, I don't know if we agree on it or not, but gradually, not radically, but gradually convert to clean energies that include small modular nuclear to get away from fossil fuel production. NuScale's a company coming on strong with that, for example. Solar's not ready. Electrical vehicle transportation is simply not sufficient, not ready yet. I think we need to reverse CO2, organic agriculture, reforestation. People are doing that. Flash forests. A brother's who's I think in Canada, the forest near their home was burned out, and they're doing that. They're seeding by drone. Very interesting. Land use greening in cities to reduce heat islands, flat roof plants, stuff like that. Now, if people conclude the warming is unacceptable, there are opportunities to reduce the warming while we catch up in technologies that sequester or convert to non-fossil fuel power production. Solar geoengineering can be used to inject short-lived aerosols, especially at the poles. It's risky, but I think it should be researched and considered. The problem is it creates a moral hazard. Hey, we don't need to worry about warming anymore. Let's just cook it up with CO2. We don't have to, with coal or whatever. We don't have to worry anymore. So there is a problem with that. There are many problems, but I think it is a time to act. That's it. Thank you.
Thank you. Thank you very much, Dr. Combs. You've given us indeed a lot to think about, and thank you for your very learned and also precise presentation. Now, I'd like to turn, before we have a little give and take between our speakers, I'd like to turn to our commentator, Dr. Staffan Berg. Dr. Berg has his undergraduate degree in chemical engineering from Chalmers University of Technology in Sweden. He later earned his MDiv and DMin degrees at the Unification Theological Seminary, which is now known as the HJ International Graduate School for Peace and Public Leadership. Dr. Berg is Executive Director of the Universal Peace Federation, USA, in Arizona, us.upf.org, and he is also the US National Coordinator of the International Association of Academicians for Peace. Welcome, Dr. Berg. We're looking forward to your comments. The floor is yours.
Thank you very much for your kind words. And also thank you for Dr. Hiroi and Dr. Combs. You did outstanding jobs. That was very good. Your sensitive evaluation of data and your take on it. I applaud your research and learning. My comments is not going to deal so much about data points as you did, but it's going to be more about values, and because facts and values are intimately related. And even on Dr. Combs' last slide, we found the issue of moral hazard. Shall we do it or shall we not do it? So this is a value questions. Free and honest exchange of ideas bring progress, and we have that on this forum, and I'm so glad for that. And, we look with glee to the past when authoritarian social hierarchies put a lid on the debate, like Galileo, who was faced the Roman Inquisition, 1633, for saying that the Earth might even revolve around the sun. And that was interesting days. We moved on. And the founder of IAAP and UPF, Dr. Hakshahan Moon, is often called the mother of peace. She says that human history has been male-dominated, and I'm sorry to say we got all guys on this panel, but anyway, maybe some women will chime in. She says that now's the time to value women, especially loving mothers, for their insight. And values, my own wise and lovely wife have many times said, I told you so, after I rushed on to do something, maybe not have been the best. So they have a very valuable intuitive sense of that goes beyond facts and figures. And I can only appreciate her wisdom if we, like true parents, sit down and discuss family matters. If we are at war, it's hard to discuss. And these days, there's much name calling happening between climate, so to say, activists and so to say climate deniers in the media and in politics. I know they are searching for clicks and votes and so forth, but still, it's kind of not a civil interaction that goes on there. And modern inquisition include fact-checking and deplatforming, and as we all know, that really took off during COVID. The US and Chinese lockdowns and coercive measures are still fresh in memory. Maybe somebody is still fearful about it. But about the climate debate, there is a statement that's floating out there, often repeated, that 97% or that all scientists believe in climate change and they all agree about something, and that deniers are just fringe crazies and who must be suppressed because the facts are wrong or whatever. But, I'm sure you're with me in saying that cannot be correct. 100 people all having the same view, that doesn't happen. It's more like, sounds like some kind of election result statement from a totalitarian nation, and I don't think we will. I'm not appreciating that kind of argument. And as evidence, I just want to point to John Clauser, who was a winner of the 2022 Nobel Prize in Physics for his work on quantum mechanics. He recently signed the World Climate Declaration, and the link to it is in the chat, saying the climate declaration saying there is no climate emergency. And he was the second Nobel laureate to sign. Dr. Ivor Grever was the first. And it's more than 1,600 people now that are on that paper. And the reason for Dr. Klausner was none of the climate models now in use, UN's IPCC or otherwise, adequately account for cloud coverage. And I took note of Dr. Hiroi's greenhouse gas curves there. He had CO2, methane, O2, but no H2O. Then there was even commented on by Dr. Combs about the picture from sky. I mean, we see picture of the Earth, blue-green, and then these white patches of cloud that deals with that albedo he was talking about, the reflectivity. And, it does change things. But going on to values, publish or perish is an old dictum. Scientists must publish research paper to get new grants, become famous, and keep going. To speak out, either they have to be a Nobel Prize winner like Klausner and Grever above, or many times have left a university career. There are names in the media who are more in the private employ and now speaks out. Dr. Judith Curry, climatologist, Björn Lomberg, physicist, Dr. Mark Mills, Dr. Stephen Konin, to name just a few. And I'm going to finish my comments here with just kind of an ironic story from just 2 months ago. You might have heard about it. It's Dr. Patrick Brown is an expert of earth and climate science. He was formerly with Johns Hopkins University. On September 5th, he wrote a story in the Free Press, and you find the link in the chat, on the headline, "I left out the full truth to get my climate paper published." He said, "I just got published in Nature," which is a prestigious academic journal, "because I stuck to a narrative I knew the editors would like." And he said, that's not the science should work. He and 7 other co-authors had examined climate change and in a paper published just a few days before in August this year said, "Climate warning increases extreme daily wildfire growth risk in California." And the study was widely cited because it was published in Nature, but it was missing, deliberately missing some key facts. So he said, Dr. Brown said, I knew not to try to quantify key aspect other than climate change in my research because it would dilute the story that prestigious journals like Nature and its rival Science wants to tell. And he's got 3 tips for what to do. He says, urgently warn the public about the dangers of climate change. And that kind of makes a climate of fear, no pun intended, but fear to circulate and people not to think so clearly. Omit relevant factors is number 2. And 3, use eye-popping large numbers. And he used those tips in his paper. He said, in my paper, we didn't bother study the influence of these other obviously relevant factors. He said, noting that, for example, more than 80% of wildfires in the US are caused by humans. So he omitted a factor that, is responsible 80%. Wow, that's kind of interesting. So he had made a value judgment in what to publish. So again, it's not just facts, but facts and values are connected. So anyway, with that, I want to just throw out to the other panelists here to continue on the debate. Thank you so much.
Thank you. Thank you very much, Dr. Berg. Okay, very good. So now we have, say, a minute-ish for each of our presenters to respond either to Dr. Berg's comments or perhaps to each other, but very briefly, because we have some questions in the chat we want to get to. Dr. Hiroi first, I guess.
Yes, thank you so much for Dr. Berg's comments. Yes, it is true that one side has been kind of suppressed as a kind of conspiracy side or something. Both sides of environmental, optimism or pessimism should be shared. I think disregarding the H2O effect is really serious. H2O clouds can have the largest greenhouse effect, but on the contrary, it can reflect sunlight. So it is a very complex effect. So in my slide, I showed 3 lines of snowball Earth. In the past, we had several times the entire planet was, glaciated. So it has kind of a positive feedback effect. It can go runaway colder state by reflecting all the sunlight energy. When it's covered, and then they will increase the entire planet. So there are many complex mechanisms on the Earth that we may not know. So I would recommend any kind of environmentalist who hates CO2 as like enemy should calm down. That we have to learn more intricate mechanism of this mysterious planet before taking any aggressive action. Especially wind energy, solar panels are not really practical and sometimes destroy the earth. In Japan, they are cutting the trees and putting solar panels. That's not the way we should do. And then plants need wind to evaporate the vapor. So if wind power is taken away by the turbines, then plants cannot really photosynthesize effectively. So we have to understand everything before taking aggressive actions. That's my 2 cents.
Thank you very much. And Dr. Combs, would you like to make a comment?
Sure, I think a lot of these points are very well taken. Albedo is a critical factor in long-term climate. Usually water vapor and clouds, they average out because they easily wash out or build up in the troposphere. But albedo in general, ice cover is critical. And surely cloud cover is important too. I was initially a skeptic because of the politicization of this issue. And I was very disturbed by some of the stuff. But Judith Curry was one of the people that was she felt she had to exit the discipline. She was a full professor at Georgia Tech because of the hostile environment, because she challenge some of the this global warming hysteria, right? So, and these points are well taken. I think I read the same letter that Staffan read, and I think that's true. It's a real. It shouldn't be true, but it is a reality. Even the Hadley Climate Research Unit version 3, version 4, version 5 all look steeper as time goes on. I called that human-made global warming by data version. You know, so there's confirmation bias. There's a lot of difficulty in the area. However, it doesn't. You can't ignore the data. The data, you might get a few percent here, few percent there, but you can't ignore it. And that's what eventually convinced me, oh yeah, this is real. And then the question is, what do we do about it?
Very good. Okay, thank you very much. The issues are percolating around. I want to turn to now one of the questions that's come in at the chat. With apologies in advance, I'm going to summarize it. This is from Frank Bell. And he's basically asking, while worldwide changes are relevant and science is important, he's asking, what about engineering solutions to help mitigate the impact? As particularly the impact, if we're talking about an increase in severity of disasters. And so you can see on the chat, for those of you who have it, he explains more about an international strategy for disaster reduction, for example, and other kinds of initiatives to mitigate some of what may be the effects of climate change and global warming. So the focus then is on the question of what about engineering solutions? And if I may just add that even if it's part of a very long time frame, still, what can we human beings do? And how does engineering fit in this? So let's see, Dr. Hiroi, Dr. Combs, who would like to be first?
I might be able to.
Okay, Dr. Combs.
A little bit. My understanding of engineering, they're engineering ideas to sequester carbon dioxide, but they're very expensive. Reforestation and organic agriculture might be a lot cheaper, but you still have problems in trying to mitigate something that is being caused by ourselves. If we don't like it, we better change that. That is, what is the cause? Fossil fuel burning. So the engineering, in my opinion, should be invested in going to alternative energies. I saw one comment here about fusion. Fusion is oncoming, but not proven yet. I know MIT had a consortium. They said 15 years from, that was 5 years ago, we'll have fusion break even with a tokamak. That's because of advances in high temperature superconductors. So wonderful. Fusion is great, but we don't have it yet. So fission is the answer to me. And it will be answered. The small modules can be used all over the world. We may have to help people that are poor countries to afford those modules to be able to bring more wealth into their society, because energy production is almost equivalent to wealth. Okay, good.
And you answered the question as well that William Stoner was asking. So very good. A question from Wayne Hankins about how the sun affects weather patterns. So Dr. Hiroi, let's toss that one to you. How about?
So as I mentioned, the Milankovitch cycle is almost all the mechanical way that incoming sunlight changes. However, sun has sunspots. Those dark spots can change the energy from the sun, and also sun is growing and also aging. So it has a different history. In the past, it was brighter at one point, and then it decreased. So we still have some ways to address this issue, but those are much longer in time scale than our civilization. So you can treat the sun almost a constant. Um, then what you can change is mostly, as Andy mentioned, the atmospheric content and then our ways of using energy. However, I don't think current environmental activist way of reducing CO2 is always correct, because you cannot increase entropy of the Earth. We have a negative, income and a budget of entropy. We get energy at a higher temperature, 6,000 radiator temperature, and emit a heat at 300 Kelvin. That's how we, reduce our entropy. But many of the recycling or clean energy mechanisms, they are producing more CO2 or entropy. That is devastating for the system of the Earth. So we have to really think, holistically in that sense.
Very good. Thank you, sir. I'd like to take one more question, and this one I want to direct toward Dr. Berg. It's a kind of political question, if you will. So from Sebastian Humer, how can we get, assuming that action needs to be taken, that's his first point, how can we get totalitarian governments, especially China and Russia, to collaborate together with others in dealing with global change? Well, Dr. Berg will give you the first shot on that and see if anyone else wants it.
Well, that's a million-dollar question. I wish I could answer that. How do you get somebody who has totally different ideas to agree with you? Currently, there are 2 coal plants built in China, new ones, every month. They're increasing their production of energy through coal, burning coal. They're currently about 30% of world production is in China. And then we have, that is where they're going, burning coal. And Russia is kind of pushed to the wall here with energy. They want to sell power because that's how they made their foreign currency. And now with the war going on, they're in the tight spot. So I wish I could answer that, but anybody who, even if we zeroed out our US production of CO2, carbon dioxide, whatever is produced in China is just like we just a blip in the drop in the bucket. What we do, nothing what we do really has an effect on what's going on globally. But I want to mention one social value issue that we haven't touched, and that is Africa, especially, and underdeveloped nations. We prosper and others prosper because of easy, available, free energy or cheap energy. And if we went, like all nations, went from cutting wood to get energy. And they do that in many parts of the world. They don't have oil or anything similar. They cannot do it. So they are poor. They can't. Cars, well, not many cars are driven by wood. That is not. So how can we be fair? What is it fair? Should we just keep this first world problem, or shall we share some of our wealth? Shall we say you can't have petroleum products either, and you stay poor? I mean, these are issues that are also big on the global scale.
So we will definitely need to have another seminar on this kind of a topic and start to get into those moral issues that are also swirling around, no doubt about it. Before we close out, we have our national president of UPF, Dr. Michael Jenkins, joining us on this call. And I would like to invite Dr. Jenkins to give us some wisdom on all the issues we've raised so far. Thank you. Dr.
Well,
Jenkins.
I want to thank you, Dr. Selover and Dr. Combs. I really enjoyed your presentation, and Dr. Hiroi, and also Dr. Berg. I think it was a great beginning. I think there's a lot more to discuss. I think that we need to understand what is causing the issues that are making radical changes in our weather and environment. I think it is important to understand it. Solutions, I think we'll need to work on that. It's very interesting to hear that the concept of removing carbon dioxide from the air it's not really achievable so easily. And also stopping the emissions, that is encouraging if we could go to non-carbon sources of energy. It's very interesting. I think I want to hear more. I'd like us to do a couple more of these, and Dr. Combs, if you can recommend, also others that could join you in a discussion. We really want civility and respect. And Dr. Hiroi, I thank you for giving us hope that we'll still have some land to stand on. God bless you for that. But at the same time, I don't want to lose Florida. I was so shocked that Japan and Korea are still going to survive after all that. But boy, it's not a good news for South America.
A lot of mountains in Japan and Korea. So
I don't think that is the what mankind wants or what heaven wants. So I think we got to find a solution. I'm trying to understand it myself because I've read both sides of the story, and I'm very interested to study more because I think that I'm glad that Dr. Combs, you were able to find clarity for yourself on what's really happening. So we respect that. I've read a lot on the topic. I thank Dr. Berg for bringing up the questions. I think that if we could remove the politics from the discussion and have a real discussion, we might be able to find some pathway to improve our situation. So I'm very hopeful there. I think we can solve it. I think nuclear power is also very important for the future. But I also think that, when we have China, who is not cooperating at all with this whole perspective of how to reduce carbon emissions, that doesn't mean we can't do it or we shouldn't do it. We should be the example. But, I think that what Dr. Berg brought up is actually what I've read, is that even if we cut all of America's carbon emissions, we won't solve the problem. That doesn't mean we shouldn't do it, but we have to solve this problem. I think it's a real problem. I think man is meant to be the steward of the earth, and we haven't done a great job, but we're getting better. I remember years ago when I was in the seminary up in upstate New York, we couldn't eat fish out of the Hudson River except once every 2 weeks, I think it was. You could eat fish out of the Hudson River once every 2 weeks. The water was so polluted, but we were able to clean that up. And that's encouraging to me. I do believe through scientists like Dr. Combs and Dr. Rowe and also scholars like Tom and Staffan, we can find solutions, but we got to work together. So this is a wonderful experience to be on this topic, and there's no anger here. There's no hand grenades. It's I think we can discover a lot more. Thank you very much, Dr. Selover, for hosting this, and we really appreciate the whole contribution here. Thank you. I'm in full support. Let's get Dr. Combs' recommended best scholars to join him and help us probe deeper into anthropogenic creation of carbon emissions and how that's affecting things. And let's also see how, the topics of the sun. And I was surprised. Now, I don't know if I heard it right, but Dr. Rowe, it appears that even though ice is being reduced on the polar cap, it also is being gained in other areas. I never heard that one before. So that's encouraging. But I think really wonderful. I can't thank you enough. I was hoping to have this program. Thank you.
Good. Thank you very much for your encouragement, Dr. Jenkins. We're very glad for your comments as well. So we've reached the 1 hour mark, a little bit over. So we'll end our official program here and stop the recording. However, those who would like to remain on Zoom for a few minutes of informal discussion are welcome and invited to do so. So